Bismillahirrahmanirrahim. Assalamu alaikum. Today we will discuss an important topic, that is the Hund's rule. First of all, the statement of Hund's rule. According to this rule, if degenerate mean orbital of the same energy are available and more than one electron are to be filled in them, they should be placed and different orbitals with the same spin rather than to put them into the same orbital with opposite spin. This is the statement of Hund's rule. It is to be noted here that different orbital belonging to the same subshell are degenerated orbital. Degenerate orbital mean the orbital having same energy, that is called degenerate orbital. For example, we have three orbital of p, 2px, 2py and 2pz are degenerate orbital. So S, there is also one S orbital, that is the degenerate orbital of S subshell, and P D subshell orbital dxy, dyz, dz square, dx square minus y square, dxyz. These are the degenerated orbital of D subshell. So Hund's rule state that if we have electron are available that are putting first place to the first spin singly, and then they are placed doubly at the same spins if we put these into different opposite spins, and if we put single electron that are placed in a same spin in orbitals. So these are subshells and these are degenerate orbital. So S subshell, there is a maximum 2 electron in S subshell. So we write this date with different spins, and P orbitals we have 6 electron maximum. These are 6 electron and P orbital px, py, pz, and D orbital we have 10 electrons. So we write this date according to Hund's rule: 2 electron placed in this and 2 electrons. This is the according to Hund's rules. Now 14 electron F subshell, there are maximum 14 electrons. So 2 electron, 2 electron, 2 electron, 2 electron, and these are 14 electrons. This is the Hund's rule. So we write this electronic configuration according to Hund's rule. For example, we take an example. We have hydrogens. To apply Hund's rule on these hydrogen atoms, 1s1, 1 electron in its shell. So we write 1s with same space. In another example, we have heliums. Atomic number of helium is 2. 1 is 2. The configuration according to Hund's rule, there are 2 electrons in subshell in orbital of s orbitals. Now we take another example, nitrogen. We have an example of nitrogen, 1s2, 2s2, 2p3. This is the 2 electron in s subshell and 2 electron in another s subshell and 3p electron. We write this date with single spins, 1 px, py, pz. These 3 electrons are placed in 3 orbital of p subshells. So this is the wrong electronic configuration, because here the spin, we see that the spin is not in same direction. This is the wrong electronic configuration. If we see this configuration, the spin is downward direction, that is anti-clockwise. So this is the true electronic configuration, right electronic configuration. If we are look this is the electronic configuration to we see the electron, that is 1, 2 electron, 3 electron. This is also the against the Hund's rules. This is a wrong electronic configuration, because according to Hund's rule, electron are placed in an orbit singly. First it will fill into singly and then will be doubly. Here one orbital is left vacant. That is the wrong electronic configuration. So another example, we take higher atomic number. For example, we have cobalt. The atomic number of cobalt is 27. So the electronic configuration of cobalt is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, and this is a 2 electron in the subshell and orbital of s. So according to Hund rule, this is their 2 electron will place in s subshell with double electron will place with opposite spin, and this is another 2s2. This 2 electron will place according to Hund rule, and 2p6. This is a 3 electrons placed according to Hund rule with the different opposite spins. 6 electron px, py, pz, 3s2. These 2 electron will place according to Hund rules with opposite spins. 3p6, 4s, 2, 3d7. So this is the right electronic configurations, and if we look here, this configuration, this is the wrong configuration, because this orbital is left according to Hund rule. Electron are placed singly with an arrow, single arrow, and so there is finally a double arrow. Here this is the wrong, because one orbital left vacant. And if we see this is also a wrong electronic configuration. This is against to Hund rule, because this is against Hund rule, because we see here the spin is different. One is clockwise, one is anti-clockwise. According to Hund rule, the spin are and the same spin, that is clockwise or anti-clockwise. So here different spins. So this is the wrong electronic configuration. If we see here, this is according to Hund rule, 3d7, 7 electron, 2, 2, 4, 5, 6, 7, and this is the right electronic configuration, because here we see the electrons that are spin is downward direction, anti-clockwise. So this is according to Hund rule. So this is our today lecture. I hope you will enjoy these lectures. And finally, requested to the new viewers, please subscribe, like, share and my channels and watch video. Thank you very much.